Hi friends, so now we're gonna take things to the next level where we're gonna do advanced analytics projects using advanced SQL techniques. My name is Baraa and I lead big data projects in big companies. So that means I'm sharing with you not only theory but as well real life skills. So now we're gonna do different types of analysis on our datasets, like track changes over time, measure the performance, segment our customers and products, and many other cool stuff. And at the end, we're gonna implement two business requirements in order to generate two amazing reports using SQL. And by doing this project, you will be ready to analyze any datasets in any domain. And as usual, everything is 100% free, no hidden costs. So grab your cafe and let's jump into the project. Alright my friends, so now if you want to do data analytics projects using SQL, we have three different types. The first type of projects you can do data warehousing. It's all about how to organize, structure, and prepare your data for data analysis. It is the foundations of any data analytics projects. And in the next step you can do exploratory data analysis, EDA, and all what you have to do is to understand and cover insights about our datasets. In this kind of project you can learn how to ask the right questions and how to find the answer using SQL by just using basic SQL skills. Now moving on to the last stage where you can do advanced analytics projects, where you're going to use advanced SQL techniques in order to answer business questions like finding trends over time, comparing the performance, segmenting your data into different sections, and as well generate reports for your stakeholders. So here you will be solving real business questions using advanced SQL techniques. And now the type that we're going to cover is advanced analytics projects using SQL, where we're gonna write complex SQL queries to answer real business questions. So we're gonna use the advanced window functions, the CTE subqueries, and we're gonna go and script two big queries in order to generate two reports. So with this type of project, you will learn how to solve real business questions using advanced techniques. Alright my friends, so the first step in any data project is that we need datasets. If you have done the previous project where we have built the SQL data warehouse, then you have everything, the data and the database, so you don't have to worry about it. But if you skip that, which I don't recommend, I still have prepared for you the files and the database. So let's get the data and create our database. Alright, so now if you go to the link in the description, we're gonna go to the downloads, and of course you can subscribe to my newsletter. And then here we have the SQL course materials, and here we have a link for data analytics projects. Let's go to the link, and now here you have some important links like downloading the server, the management studio where we're gonna write our SQLs, and as well there is a link to the Git repository, and as well what is very important is to download all the project files. So click on that and download all the files. Now extract the file and put it somewhere safe at your PC, and now inside it you can find all the scripts and the datasets. Now there is like three ways on how to create the database in SQL Server. So the first one is by executing scripts. If you go to the scripts over here, the first one we have a file called init database. Just go inside it and copy the whole thing, and then let's go to SQL Server. Now make a new query and make sure you switch to the master database and then paste the whole code. So now what you are doing here is we are creating a new database, we are creating a schema, and then three very important tables that we're gonna use in our data analysis. Now there is like only one thing that you have to change in this script, and that is the path of the files. And once you have done that, just go and execute the whole script. And now as you can see, everything is done and there is like data inserted. Now if you go to the left side to the database and refresh, you can find a new database called Data Warehouse Analytics. And if you go inside the tables, you will find our three tables: customer, product, and sales. So this is one way on how to create the database. The second method is to go to the databases over here, right click on it, and say a new database, and for example let's call it Data Warehouse Analytics. I'm gonna call it 2 because I have already one, and then click OK. And with that you have a new database. So what we're gonna do now, we're gonna right click on it and then go to tasks and then import flat file. And now what we can do, we're gonna go and import the CSV files to our new database. So we can go next, and then you have to go and locate your files. I have them somewhere over here. So datasets, CSV files, and we have to focus on the gold tables. So I'm gonna go and select this one and then next. Now I'm just getting an overview of my data. So next. Now just to make sure that you are not getting any error corner, I'm gonna go and allow nulls, and that's all. So next and finish. So perfect. The data has been inserted. Now let's go to our database, tables, and as you can see, we have here our new table. So you have to go and repeat this 3 times in order to import the data. Well, you can use this method if the first method didn't work, but I really recommend you to use the script in order to create the database. The third way is to go and restore the database itself. Now, how we're gonna do it? We're gonna go again to the datasets. And as you can see, we have here a database backup. So as you can see, we have here a PAK file. So now what you have to do is to go and copy that. And then we're going to go to the database location. So it really depends where you have installed the SQL server. So currently I have it here, program files, Microsoft SQL Server, and then the Express MS SQL backup. And you have to place the file over here. So I have it here, Data Warehouse Analytics Backup. And now all what you have to do is to right click on the database and then say Restore Database. And then we're going to go to the device, 3 points, and we're going to say Add. And now you can see our database, Data Warehouse Analytics. Once we say OK, and then OK. And now since I have it already, I will get an error. But once I click OK, the whole database can be restored without running any scripts. So those are the 3 ways on how to create the database of the projects. And if you have built with me the data warehouse projects before, you don't have to do it because we have built that together. So pause the video and get the data for the projects. Alright, so for this project as well, we have a roadmap where we're gonna progress through different type of steps and analysis. So we're gonna do many stuff like change over time, cumulative analysis, performance, data segmentations, and other end reporting, and all using SQL. So let's start with the first step in the roadmap. We're gonna analyze the change over time. So let's go. Okay, so now what is change over time? It is a technique in order to analyze how a measure evolves over the time. And this is very important in order to track the trends and as well to identify seasonality of your data. And the formula for that is very simple. We're gonna go and aggregate a measure, but this time based on a date dimension. For example, the total sales by a year, the average cost by the month. So if you combine any aggregated measure together with a date column or dimension, then all what you are doing is you are analyzing the change over time. So for example, we're gonna go and break our measure, this time for example by the years. And with that, we can track immediately how our business is doing over the time, over the years. So for example, we can see here the best year was 2024, and then we have really hard decline in our business in 2025, and then slightly it's going up in 2026. So with that, we can quickly analyze the trends of our business. So now let's go and check the trends and the changes over time in our business. Okay, so now let's analyze the trends and changes over time in our data. And in order to do this kind of analysis, usually we target the fact table because there usually we have our measures and as well dates. So we have the order date, shipping date, and due date. Now what we can do, we can go and analyze there the sales performance over time. So as we learned, all what we need is a metric and a date. Let's go for example and select the order date and as well one of those measures, sales amount, from our fact table. So let's go and query it, and we can go and order the data by the order date ascending. So let's go and execute, and as you can see we have nulls in our data. What we can do, we can go and filter those data out, we don't need it. So we're gonna say where order date is not null. So let's go and execute it again. Alright, so with that we don't have those orders. Now as you can see we have sales over time, right? We have a date and we have a measure. So this looks really good. But now what we're gonna do, we're gonna go and aggregate the data by the sales amount. So let's go and say sum, and we're gonna call it total sales, and then we group up the data by the order dates. So let's go and execute it. And with that, as you can see, for each day, we have the total sales. So now the granularity of our data is the day. And we can say, of course, now we are analyzing the sales over time, but usually we don't aggregate the data on the day level. We want to have higher aggregations. For example, let's go to the years. And now in order to change the dimension date here from a day to a year, we have to use date functions. And there are a lot of date functions in order to extract the date part. And now in order just to get the year, we have a quick function called year, and it's gonna convert our date to year. So let's call it order year. And of course we have to go and group up the data by the year and as well sort it by the year. So let's go and execute. Now we are at the year level and we have only 5 years. So that means we have changed the aggregation from from the day to year. And now it is very easily to analyze the performance of our business over the years. So the first year was the lowest, and you can see 2013 is the best year in our business. And then it is declined massively in 2014. And now, of course, we can go and add more measures to our data, not only the total sales. For example, let's go and calculate the total number of customers. So we can say count distinct customer key as total customers. So let's go and execute it. And with that, we can check, are we gaining like customers over the time? Is there any trends that we can see? And we can go and keep extending stuff. Like we can go and add the total number of quantities. So summarize quantity as total quantity. So let's go and execute. And with that, we have really nice picture in order to understand, is the revenue increasing or decreasing over the time? What is the best year, the worst year? Are we gaining customers over time? Is there any like trends that we can spot? Now, by looking to the result, you can see this gives us high-level, long-term view of your data. And of course, it helps for strategic decisions. And now what we can do, we can go and drill down to the months. So we can go and aggregate the data by the month, regardless the years, in order to give us an idea how each month is performing on average. So all what you have to do is to switch the function from year to a month like this. And of course, for the group by and the order by, let's go and execute. And of course, in the output, we will get all the months. And guess what? Which month is the best for sales is of course December, because you have all those Christmas and stuff. And the worst month, as you can see, is February. So with that, we are understanding the seasonality of our business and the trends patterns of our business. And as you are not including the year in our analysis, you are aggregating all the data from all years. Now what we can do, we can make it more specific for each year, where you go and add the year informations to our query. So we're gonna have both a year and months. Let me just change this to a month. And of course, we have to go and add it to the group by and the order by. So let's go and execute. And with that, we are aggregating the data of a month of specific year. So now we have all the months of all years. And now if you want to focus on only one year, what you can do, you can go and filter the data by the order year. And with that, you can see how the data is evolving over time. Now, of course, in SQL, we can go and format the date differently. So instead of using the year and the month in separate columns, what we can do, we can use the date trunk function. So instead of here, we're going to say date trunk. And if you want the granularity of your date at the month level, you're going to say month and then the date. And with that, you will get both the year and the date. And let's call it order date like this. So let's go and execute. Now at the output, we will get exactly the same result as before. But instead of having like two columns for the year and the month, we have everything in one. And because we said the month, that means SQL gonna go and remove all the days. So as you can see, it always starts with the 1, so the first day of the month. And with that, you will get one row for each month for each year. And if you want to change that quickly to a year, you go and change the date parts to a year, and you will get the granularity of the year. Now, if you don't like this format and you would like to have your specific format, what you can do, you can go and use the format function. So format, the first argument is gonna be the date, and then you go and do your format that you want. So for example, it starts with the years, and let's say I would like to have the abbreviation of the month name. So something like this, and of course, group by and order by. So let's go and execute it. And with that, we got our format, the year, minus then the abbreviation of the month. But here you have to be careful which function you are using, because the format you will get in the output is string. And as you can see, you cannot sort it correctly. So the data here is sorted by the year, but not by the month. But if you are using date trunk, you can see the data is correctly sorted. So if we switch it to a month, it will be as well, okay? So everything is sorted correctly because the output here is a date, and SQL gonna sort the date correctly. It is not string. And if you are using the year and the month, the output here gonna be an integer, and sorting an integer is not a problem. So of course you can go and pick the one that you like. So that's it. Let's go and execute it. And now you can go and keep analyzing by finding another date in our datasets and another measure. So as you can see, it is very simple. Okay, so that's all about how to analyze the trends and the change over time. Now in the next step, we're going to do some kind of advanced aggregations by doing cumulative analysis. Okay, so what is cumulative analysis? It is aggregating the data progressively over the time. And this is very important technique in order to understand how our business is growing over the time. So how our business is progressing over the time, whether it is growing or declining. It is very interesting analysis. So the formula gonna be very similar to the changes over time, but instead of having a simple aggregations on the measure, we're gonna aggregate our measure, but this time cumulative. So we are like adding stuff on top of each others. And the data again gonna split it by the date dimension because we want to track the progress over the time. For example, we can find the running total of sales or the moving average of sales by a month. So now let's have again our simple example where our sales is splitted by the years. Now this is the classic change over time, but in order now to make it cumulative, what can happen? We're gonna take the measure and add to it. For example, 2024 we have 300, and now for 2025 we're gonna add the 300 together with the 100 in order to make it cumulative. So for 2025 we're gonna have 400, and the same thing for 2026. We're gonna go and add the 400 together with the 200, and with that we will get 600. So as you can see, we are keep adding the values in order to generate something called cumulative value. Now for this type of analysis we use in SQL the aggregate window functions in order to find out the cumulative values. So now let's go and apply our formula in order to find whether our business is growing or declining. So let's go. Okay, so now we have to analyze the following. We're gonna calculate the total sales for each month and as well the running total of sales over time in order to analyze the trends. So let's see how we're gonna do that. Let's start with the easy stuff where we're gonna calculate the total sales for each month. So we are calculating the changes over time and we have already done that. So all what we need is a date and a measure. Our date gonna be the order date and the measure gonna be the sales amount from our fact table. So let's query this. And now we want to find the total sales for each month. That means we're going to change the granularity of the order date from a day to a month. And I usually like using the date trunk for this kind of tasks. And the granularity going to be the month. So this is the order date. And now for the sales, we're going to use aggregate function sum sales as total sales. And of course, we have to go and group up the data by the date. So let's go and execute it. So as you can see, we have now the total sales for each month, and don't forget to get rid of the nulls. So we're going to say where order date is not null. Now it looks better, we don't have nulls, and of course we can go and order the data by our date. Now our measure is just aggregated for each month individually, right? But we don't want that, we want to have like a running total. So we'd like to have like cumulative metric. In order to do that, we have to use window function. So let's go and do that. We will use a subquery for that in order just to make it simple. So what we need the order date, and let's say the total sales. And here we have to have our window function. Then we're going to put the rest in a subquery. And of course, we can go and get rid of the order by, because anyway, our data going to be sorted using the window function. So now let's start writing our window function. We will have the sum of total sales. So we want to summarize those new values, and we're going to build the window function like this over. We don't have to go and partition anything. So we can go immediately and say order by our new order date that we have calculated, and we want it to be ascending. So actually that's it. So as running total sales. So let's try that out. Now, if you look to the result, you can see that all those values are cumulative, and it is working like this. The first total sales is equal to the total sales because previously we don't have anything. Now for the next row, what's gonna happen is SQL gonna go and add this value to the previous one, and with that we get the running total value. Now moving on to the third row, SQL gonna go and add all those three values together, and of course this is gonna give us the running total for this month, and so on. So as SQL is moving through the window, it is always adding the current value to all previous values, and this is because of the default frame of the window. The frame gonna be between the unbounded preceding and the current row. So that means, for example, if we are at this row over here, current total sales for this month is this one, and the unbounded preceding is all the values before this month. So that means we are getting all the previous values together with the current value, and with that we will get the effect of the running total sales. And now of course, as you can see, it is going through all the years, right? Now we can go and limit the running total for only 1 year. So for each new year it has to reset and start from the scratch. So that means we are partitioning the data. data. For each year, we would like to have partition. For the first year, it's going to be 2010. It is one row. And for the 2011, we're going to get the whole partition over here. So in order to partition our window, it's very simple. We're going to go and say partition by the order date. That's it. Let's go and execute it. Now let's go and check. For the first partition for 2010, you can see the running total is the same as the first month, but since we have only 1 month, that's it for this year. Now as we go to the next year, as you can see, it resets. So you can see the running total sales for 2011, it is exactly as January. It is not adding up now the value of the current value with the previous one, because the previous one is outside of the window. So as you can see, we are getting a running total for the whole year, and once we hit a new year, it is going to reset. So it is working, and this is how you can create cumulative values in SQL. And of course, if you would like to change the granularity of our data, it is very simple. All what you have to do is to go over here and say instead of month, we're gonna make it as a year. And of course, don't forget to change as well the group by. So let's go and execute, and with that we are creating cumulative values for each year, but of course it makes no sense to partition by the years. Let's go and remove it and execute it again, and with that you are creating the running total sales, the cumulative metric over the years. So as you can see, it is very simple. Now we can go and add like another measure and another aggregation. Like for example, instead of finding the running total, we can find the moving average. So let's for example go and get the moving average of the price. So first we have to calculate the average of the price as average price. And now what we have to do is to go and make another window function over here where we are saying average, the average price, and we're gonna go and call it moving average. That's it. So let's go and execute it, and with that you are getting the moving average price of our sales. Alright, so now you might still asking what is really different between using a normal aggregation and cumulative aggregation. Well, we usually use normal aggregations in order to check the performance of each individual row. Like if I want to see how each year is performing, I'm gonna go and do a normal aggregation. But if you want to see a progression and you want to understand how your business is growing, you have to go and use cumulative aggregations, because you can see easily here the progress of your business over the years. So there is like a difference between using cumulative value and a normal aggregation. Alright, so with that we have done with the cumulative analysis, and you have learned all different types of aggregations. Now the next step in our roadmap, we're gonna do performance analysis. Okay, so what is performance analysis? It is the process of comparing the current value with a target value to compare the performance of specific category. And this can help us in order to measure the success, to compare the performance. So the formula for that is very simple. We're gonna find the difference between the current measure and the target measure by subtracting them. Like for example, we can go and compare the current sale with the average sale, or the current year sales with the previous year sales, or the current sales with the lowest sales, or maybe the highest sales. So as you can see, we are always comparing the current measure together with a target, with something else. So for example, we have here again a measure that is splitted by 3 categories. So those values are the current values. Now if we have a target, like for example the average, now as you can see for each row we have like the 200. Now what we can do once we have those two things in one row, we can go and simply subtract them. So for the A, the current value is exactly equal to the average. Both of them is 200, and the difference between them is 0. So this product is performing as an average. Now for the next one we have 300 and the target is 200, so the differences between them is 100. That means this category is performing very well, so this is a good performer. Now for the last one we will get minus 100, so that means it is below the average, so it is not performing very well. And for this type of analysis we usually use window functions like the aggregate window functions, the sum, average, max, min, or the value window functions like lead and lag. So now let's go back to SQL and apply this formula in order to measure the performance of our business. So let's go. Alright my friends, so now we have the following task. Analyze the yearly performance of products by comparing their sales to both the average sales performance of the product and the previous year's sales. Okay, this sounds a little bit complicated and serious. Let's have some coffee before we start. Okay, so what do we have over here? So it is talking about the yearly performance of products. So that means we need the order date as a dimension and as well the product, and the measure that is used over here is the sales. So let's do it step by step. So we need things from our fact table, so fact sales, and we need the product. So I'm gonna go and get it from the dimension product in order to have a nice name. So we have to join the data by the product key, and I'm gonna go and change the alias to P, so product key. Okay, so with that we have our two tables. Now let's go and select our columns. So we need the order date, we need the product name, and we need our measure. So it's going to be the sales amount. All right, so now let's go and query those informations. Now we have to analyze the yearly performance. That means we don't need the day. The granularity is the years. So that's why let's go and convert it using year function. And we're going to call it order year. And of course we have to go and aggregate then the sales. And I'm going to call it current sales. And of course we have to group up the data by the date, the year, and as well by the product name. So that's it. Let's go and execute it. And of course, I'm going to go and get rid of all those nulls. So where order date is not null. All right, so with that, we have solved the first part. So we have the yearly performance of the product. Now in the task, we have to compare this value, the current sales, to the average sales performance of the product. So that means we need the average and as well the previous year sales. So that means we have to compare each value to the previous year for the same product, of course. So that means things are getting a little bit more complicated, and with that we need the help of the window functions. Let's do it one by one. Let's focus on the average sales. So now what we're gonna do based on those values, based on these results, we will do new calculations and aggregations. And now in order to do that, either we use a subquery or a CTE. I'm gonna go with the CTE because it looks nicer. So with yearly product sales, this is the new name that we are giving for this results. And now what we're gonna do, we're gonna build queries on top of these results. So first of all, I will just select everything from this table, yearly product sales, just to test. So it is working. Now I'm selecting data from our CTE. So now the next step, I'm gonna go and list all the columns that I want in my results. So the order date, the product name, the current sales. This is just nicer in order to have control on which columns you want to present the end results. Now the next step, I'm gonna go and order the data by first the product name and then the order year. And with that, we can have better understanding of the results. So we can see this product has 3 years of sales, and those are the current sales for each year. So now we have to go and calculate the average of those 3 sales. So in order to do that, we're gonna use the average current sales over. We have to decide now how to partition the data. Since we are focusing on the products, we have to partition the results by the product name. So we're gonna say partition by product name. And we don't have to sort the data because we are using the average. So it doesn't matter how the data is sorted. So let's call it average sales. So let's go and execute it. And now if you are looking to the results for this product, the average sales of all those 3 values is 13,000. So now as you can see, for each row, we have the current sales and side by side with the average sales, and the same thing for the next product as well. So now since we have both of the informations on the same row, current sales and the average, the difference between the current value and the average value. So all what you have to do is to go and subtract, right? So we're gonna say the current sales subtracted by the average sales, and we're gonna call it the difference in average. So let's go and execute it. And now, as you can see, we are getting now the comparison. We have the differences between the current and the average. And of course, what I like to do is to make a flag or like indicator, whether we are above the average, below the average, or at the average. So in order to do that, we're going to go and use the case when statement. So if the difference is higher than 0, then we are above the average, right? Above average. Well, let's have an abbreviation for that. And if we are below 0, that means we are below the average, right? So below, then below average. And if it is exactly 0, else, then it is average. So that's it. Let's end it. And I'm gonna call it average change. So let's go and execute it. Now, if you focus again on one of the products, you can see the current sales of this product in 2012. It is below the average. It is really low. And for the next year, for 2013, it is above the average. It was really nice year for this product. And the last year, 2014, it was again below the average. So with that, we have really nice flag in order to see quickly whether we are above or below the average. And it is interesting to see whether we have zeros. So yeah, sometimes it is exactly like the average, and here we have like a 0. It's not below or above. So with that, we are comparing the performance of the sales of each product with the average. And as you can see, it is really simple, yeah, using the window functions. So let's go and check again our task. We have compared the current sales to the average sales performance. Now we have to compare it as well with the previous year sales. So let's go back to our example over here. This time we have to compare the current sales not with the average but with the previous year. So we don't have to write like another CTE or query. We can continue with the same results. So now all what you have to do is to access the previous year. And in order to do that, we have amazing window function called lag. So let's do it step by step. So now we're going to go and create a new column. It's called lag. I want to access the previous value of what? The current sales, right? So current sales, and over, we still have to partition the data by the product name because we focus on the products. So partition by product name. But now in order to access the previous value, that means we have to sort the data, and we're going to sort it by the years. We need the previous year. So we're going to say order by order year, and we're going to sort it ascending from the lowest to the highest. So we're going to leave it like this. And with that, this window function going to give us the previous year sales of the product. So I'm just going to call it previous year sales like this. And I think here we have something wrong. Okay, so let's go and execute it, and let's go and focus on one of those products. So now for the first year of this product, the previous year was null, right? So we don't have any data from the previous year. But for the 2013, we have a previous year of 2012. So that's why now we are getting the previous value of the sales based on the years. And the same thing for the last year over here. You can see we are getting the previous sales. So it is working. And for the next window, same thing. For the first year, you will get null, and the previous sales will get it from the previous year. So with that, we have now the previous sales. And if you check this over here, we have in the same row now the current sales of the current year, and as well the sales of the previous year. Now what we have to do, the same thing. We have to go and subtract those two informations in order to compare them, right? So we're gonna go and do the same thing. So we will get the current sales minus the whole thing, the whole window function, and we're gonna call it previous year. So difference of the previous year, and with that we are calculating the differences between them. So for this year, for this product, as you can see, the difference here is really big between the current sales and the previous year. Now of course what we can do, we can go and make as well a flag or an indicator. I'm gonna go and copy the whole thing from the previous average, but we have to go and get the right function, this, and the same over here. And now it is not above or below the average. I'm gonna say it is increasing or decreasing, right? So increase or decrease, and we can call it previous year change, and instead of average we can say no change. So let's go and execute it, and I'm having here an extra comma. Let's go and execute it. So again, let's go and focus on one of those products. For the first year of this product, there is no change because there is no previous year. For the next year of this product, we have an increase, right? Because the current sales is way higher than the previous year. And now by going to the last year of this product, we have a decrease because the current sales is less than the previous year. So my friends, we call this type of analysis year over year analysis. And if you want to calculate the month over month analysis, it's very simple. All what you have to do is to go and change the function from year to a month. And with that, you are extracting the month part. And the difference between analyzing the months and years is, of course, the scope. Year over year is good for long-term trends analysis, where on the other hand, the month over month, it is short-term trends analysis. You are just focusing on the seasonality of your data. So this is how we analyze the performance of our business by comparing the current measure with a target measure. And you can go and use different dimensions and stuff. So instead of the sales, you can check the quantity. Instead of products, you can check the customers, and you can go and compare the current information not only with the average or the previous year, you can compare it with the lowest sales and the highest sales, and it's gonna open the door for many different insights. But we are always using the same methods. Using the window functions, we compare the current value with another value in our datasets. So this is how we do performance comparison. Alright, so with that you have learned how to analyze the performance of our business. Now in the next step we're gonna do part to whole analysis. So let's go. Okay, so now what is exactly part to whole analysis? Well, we use it in order to find out the proportion of a part relative to the whole. Well, here we're gonna analyze how an individual category is contributing to the overall in order to understand what is the most impacting category to the overall business. So now for the formula, it is very simple. You have to go and pick one of your measures, divided by the total of the measure, and then multiply it by 100 in order to find the percentage by a specific dimension. Like for example, if you take the sales, so you divide the sales by the total sales, multiply it by 100 by the category. Or if you take the quantity, divided by the total quantity, and then find the percentage by a country. So for example, again, we have our measure splitted by categories, but now instead of having this number, what we're gonna do, we're gonna calculate the percentage. So for the first one, we're gonna take the 200 divided by 600, multiply it by 100. So we're gonna get the percentage 33. So once we do that for the all categories, it's gonna be now very easy to see that the category P, it is contributing to the overall number by 50%, which makes it, of course, a top performer. So you can visualize it in your head as like a pie chart, and you can see how each part is contributing to the whole pie chart. And with that, it can help us to understand the importance of each category to our business. So now let's go and apply this formula to our measures in order to understand the importance of our categories. So let's go. Okay, so now let's do part to whole analysis. All what we need, one dimension and one measure. So for example, we have the following task. It is very simple. Which categories contribute the most to the overall sales? So now let's go and do it step by step. So first we're gonna go and collect the informations. So we need the category, we need the sales amount, and those informations come as usual from the fact sales and from our dimension the product, right? So we have quickly to go and connect them using the product key. Okay, so that's all what we need for our query. So let's go and select. So we have here the categories and the sales amount. So now the first thing, we have to calculate the total sales for each category. So let's go and do that. It is very simple. So sum total sales, and we are grouping up the data by the category. So this is basics, right? Now we have the total sales for each of those categories. Now in order to calculate the percentage, we need two measures, the total sales for each category, and we have it here already. And as well, side by side, we need the total sales across all categories. So the big number without any dimension. But now as you look to the result, you can see the granularity here is that category. Now we need the total sales again by different granularity. And in order to mix those stuff together, we use the window functions. So now how are we gonna do it? Either you go over here and start writing your window function, and of course you can do it together with the group by, or you can do it as a second step in your query using either a CTE or a subquery. So I'm gonna go with the CTE just to make it clear. So category sales like this. So now let's start again, selecting the same information. So category, total sales from our table, category or CTE, sales. So let's go and execute it. So now we have the same results, and now we're gonna go and build our window function like this. So we're gonna say the sum, we want to aggregate all those values, right? To get the total sales of the whole data sets. So we're gonna say sum total sales. And now in order to get the big number, we're gonna say over, and inside it we will not define anything because we don't want to partition the data, we don't want to introduce any dimension, we just want the big number. And with that, we will get the overall sales. So let's go and execute it. Now as you can see, this is the total sales by the category. So the total sales is splitted by the categories, and this is the overall sales of all orders of everything. The highest highest number. Now, since we have them side by side, what we can do, we can very easily calculate the part to whole or the percentage. So let's start doing that. We need the total sales and we want to go and divide it by the overall sales. So we're going to take our window function and put it over here. So let's go and multiply it now with the hundreds. I'm going to go and call it percentage of total. So let's go and execute it. Now, as you can see, we are getting zeros, and that's because the total sales is not float. So what we have to do is to go and cast it to something like a decimal. So float like this. So let's go and re-execute it. And now, as you can see, we are getting now the percentages, but we have a lot of numbers after the comma. So we're going to go and round the numbers now. So let's go to the start, round, and then go to the end, comma, and let's have like 2 decimals. So let's go and execute it again. Now looks perfect. Now what you can do, we can go and add like a percentage, and with that we are converting the whole thing to a string. So we're gonna do concatenation. So concat at the start and go to the end, and let's add the percentage character. And as well, we can go and order the data by the total sales descending. So let's go and execute it. So now by looking to the result, you can see the category bikes is dominating. So it is overwhelming, top performing the categories. It is making 69% of the total sales of our business. So this means, my friends, most of the business revenue comes from the bikes. And as you can see, the accessories and clothing, they are really minor contributors to our business, which is not really good. And this is actually a dangerous thing. If you have like one category dominating your whole business, you are over relying on only one category in your business. And if this fails, this category, then the whole business is gonna fail. So by looking to this, either the business has to decide removing all those products by those 2 categories, or to focus more on bringing more revenue for the products that are inside those 2 categories. So as you can see, guys, those insights are really amazing for the business and helps the managers and the decision makers to understand what is going on quickly and make very critical decisions. And now you can see as well from the results perfectly why the part to whole analysis is very important, because by just looking to those numbers, it's going to be really hard to understand the importance of the categories. But seeing the data as a percentage, how each category is contributing to the whole sales of the business, makes it easier to understand which category is underperforming or top performing. And now you have a very simple formula where you can go and change the metrics. For example, instead of total sales, you can go and change the aggregation to total number of orders or the total number of customers. So you can go and bring any type of measures and bring it to this analysis, and you're gonna generate completely new view for the decision makers in order to develop a new strategy for the business. It was very interesting. Now in the next step, we're gonna do my favorite topic, where we're gonna start doing data segmentations using SQL. So let's go. Okay, so now what is data segmentations? What we're gonna do here is we're gonna go and group up the data based on specific range. So that means we're gonna go and create a new categories and then go and aggregate the data based on the new category. And the formula for that's gonna be very interesting. So it's gonna be, this time we're gonna have a measure by a measure, not by dimension. So you have to go and pick 2 different measures and convert one of those measures to a range or to a group, and then aggregate the data by this measure. So for example, we're gonna go and calculate the total number of products by the sales range, or the total number of customers by the age group. So as you can see, we have 2 measures and we are trying to combine them together in order to create new insights. Let's have the following example. So here, for example, we have like 2 measures, and now the first step is that we're gonna take one of those measures and convert it to a dimension, convert it to a category. For example, we're gonna say if the values are like equal or below 100, it will be converted to a category called low, and between 100 and 200, it's gonna be assigned to a new category called medium, and everything above 200, it's gonna be large. So as you can see, what we are doing, we are taking one measure, and based on the range of this measure, we are building a new categories, new dimension. And now the final step is the easiest one. We're gonna go and aggregate another measure based on the new category. So we're gonna have 7 for low, 6 for medium, and 15 for large. So with that, as you can see, we are creating new categories or segments based on a measure, and then we are aggregating another measure based off this new segments. And in SQL, in order to create those new categories and segments, we use the amazing case when statements, because it's gonna help us to define the rules, and based on the range, it's gonna go and create a new category and labels. So now let's go and apply this formula on our datasets in order to segment our data. So let's go. Okay, so now let's go and segment our data, and all what we need is two measures. So now we have the following task, and it says segment products into cost ranges and count how many products fall into each segment. So now by looking to this task, we have two measures. First, the costs, and as well the second one is the total number of products. And of course, we have to go and segment one of those two measures, and in this task, we are segmenting the costs. So we have to focus now on taking this measure and convert it to a dimension. So now all those informations are available in the table products. So now let's go and select few columns. We're gonna get the product key, and let's get the product name and the costs. That's all what we need. So let's execute it. Now, as you can see, this is our measure, the costs. Now we have to go and convert this measure to dimension. And in order to do that, we use the case when statements. We always use the case when statement in order to create new categories. So let's go and do that. Case when, let's start with the first range. Let's say it is below 100. So all the costs that are below 100, we're gonna label it with a new value. It's gonna be below 100. So now let's go to the next range. We are saying when costs, now between 100 and 500. So all costs between this range, they will get the label 100 and 500. So this is very simple. Let's go and get another range, for example, between 500 and 1000. Then it's gonna get the label between 500 and 1000. And now it depends how many categories and segments you want to create. Each row of this case when, each condition will be creating like a new value for your dimension. So I'm gonna stop with that, and I'm gonna say at the end else. So if the cost is not fulfilling any of those, it's gonna be above 1000, right? So that's it. Let's give it a name. It's gonna be cost range. So now let's go and execute it. Now let's go and check the result. For example, the cost here is 0. It is below 100, which is correct. This value is above 1000. This is between 500 and 1000. And this is between 100 and 500. So everything looks correct. Nice. So with that, we are done with the first step, where we have converted one measure into a dimension. So with that, we have now our segments. The next step is that we're gonna go and aggregate the data based on this a new dimension. So either you do it in one go, or what I usually do, I put everything in one CTE or a subquery, and I'm gonna call it products segments. As based on these results, I'm gonna go and aggregate the data. So this is my temporary results, and now we're gonna go and just aggregate the data like this. So let's get first our dimension, cost range, and then we need our measure. So it's gonna be count product key as total products. From our CTE, it was the product segments, and then group by our new dimension. That's it. It's very simple. Let's go and execute it now. Now you can see in the output, we have our segmented measure, and we can see the total numbers in each of those segment and range. And of course, we can go and order the data by our aggregation, the total products. Let's go and execute it. Maybe descending. So now, as you can see, we have a lot of products that are not costing a lot. It is below 100. After that, between 100 500, and the lowest number of products is in the range that is above 1000. So we don't have a lot of products that are costing a lot, and that's because maybe we have a lot of accessories in the business. So my friends, this is very powerful. If your dimensions in the dataset is not enough to create insights, you can take one of your measures, convert it to a dimension using case when, and then aggregate your other measures based on this new dimension. So we are deriving new informations, and as I told you, by just following this concept, measures and dimensions, you can generate endless amount of reports, even if your business or your dataset is small. Okay, my friends, so now let's go and segment something else. So this time it's gonna be a little bit more complicated. So we have the following task, and it says group customers into 3 segments based on their spending behavior. So we have the VIP customers. They are the customers with at least 12 months of history and spending more than 5,000. And the second category, we have the regular customers. They have at least as well 12 months of history, but they spend like less than 5,000. And the last category, we have the new customers. Their lifespan is less than 12 months. And we have to find the total number of customers by each group. So now here we have a lot of measures and stuff. So the first one is the total number of customers. This is gonna be the final aggregation that we're gonna do. But what is interesting, we're gonna build the segments, and this time is based on different columns. So first, it is based on a measure, the total number of months for each customer, and as well the total spending, the total number of sales. So we have the sales, we have the total number of months, and as well the total number of customers. So now we're gonna do it step by step, don't worry about it. So now what I usually do, I start collecting all the data that I need. So what do we need? We need a customer key in order to do the aggregation for the total number of customers. We need as well the sales amount, right, for the spending. And now in order to calculate those number of months, we need a date. And for that, we have to calculate the lifespan of a customer. And usually we create it using the order date. I'm gonna show you how we're gonna do it. So we need the order date. And of course, we have to select our tables. So let's start with the fact table. So fact sales. And we're gonna join it with the customers. So our dimension customers, and the key for that, it is the customer key as well for the customers. And here we have to specify which column come from which table. So the first one from the customers, the sales from the fact, and the order date from the fact as well. So now let's go and execute. Now we can see we have our customers, the sales, and the order date. So now the sales gonna help us in order to specify the range of spending. But now what is interesting, we have to calculate the lifespan. So now in order to get the lifespan, we have to find out the first order and the last order of each customer. So how many months is between the first order and the last order? So in order to do that, we need the min function for the order dates. So this is the first order, and the max in order to get the last order, right? And since we are using min and max, we have to go and group up the data. And we need to do that anyway in order to get the total spending. So for the sales amount, we're going to have the sum in order to have the total spend, total spending, and we don't need the order date, and the dimension where we're going to group up the data is by the customer key. So let's go and execute it. So now in the results, we have a list of all our customers and as well the total spending for each customer, and we have the first order date and the last order date. Now in order to calculate how many months between the first order and the last order, we can go and use the function dateDiff in order to get a new measure. So let's go and do that, dateDiff. And now since we need the number of months, we're gonna use the month, and then the second argument gonna be the first order, so order date, and the second one gonna be the latest, so max order date, and we're gonna call this lifespan. So let's go and query, and let's have a look to our results. You can see for this customer 712, between the first order and the last order we have 11 months, and for this customer over here we have 0 because the first order and the last order is in the same month, and maybe there is only one order. So with that we have the lifespan, and as you can see guys, we have derived a new measure from the dimension order date in order later to derive from this new measure a new dimension, the segments. So we are converting a dimension to a measure, and then from a measure to a new dimension. And this is usually what we do in analysis and in SQL. So now do we have all the informations for the logic? So we have the lifespan, so we have the total number of months, we have the total spending, and I think we are ready to start building our segment. So now what we're gonna do, we're gonna create the segments based on these results that we have prepared. So this result is the intermediate result before the final one. Now either you're gonna put it in a CTE or a subquery. Well, I usually go and use the CTE, it is nicer. So with customer spending, and I'm gonna put the whole thing in a CTE, and we're gonna start writing a new query from the scratch based on the intermediate results. So let's go and select again the customer key. I'm gonna get the total spending and the lifespan. So we don't actually need the first and the last order, and we're gonna get all those informations from our new CTE. So let's go and execute. And now let's start building the segments. And as usual, we're gonna go and use the case when statements. It is just amazing statements in order to derive and build new columns. So now what do we have for the first category? So they are the customers over 12 months and spending more than 5,000. So now we're gonna say if the lifespan is higher than 12 and the total spending is higher than 5,000, then we have our VIB customers. So this is the first label. Let's go to the second one. If the lifespan as well, I think more than 12. So let's go and check. Well, it is at least 12. I have here a mistake. So it's going to be larger or equal. So now it is more correct. So the customers that has at least 12 months, but they spend like 5,000 or less. So that means it's going to stay the same condition, but the total spending will be less or equal 5,000, and they are the regular customers. So they will get this label. Now, if it is not fulfilling those two conditions, what this means? This means this is a new customer, right? So they will get this label. Let's go and have an end, and let's call it customer segments. So let's go and execute it. Now let's have a look for this customer 712. So the total spending is less than 5,000. So this customer is not a VIB, and as well the lifespan is less than 12. So that means for us it is a new customer. Now the next one we have a VIB. So this customer has a history at least 12 months. So we have here 16 months, and as well the total spending more than 5,000. That's why this customer is a VIB. But now let's go and search for a regular customer 2,349. So this customer spent less than 5,000. So we are fulfilling this condition over here. And as well, this customer has at least 12 months of history. That's why we have irregular. So now, as you can see, we have derived a new dimension from two measures, the lifespan and the total spending. Now, of course, the last step, what is going to be? We have to go and find the total number of customers for each of those categories. So now what we're going to do? We're going to remove all those stuff, and we're going to start with our new dimension. And then comes the aggregation count, customer key, so as total customers. And then we have to group up the data by our new dimension. So this is going to be really annoying if I'm going to take this here and put it in the group by, because this means each time I'm changing the logic, I have to take care of that twice. One in the select statement and the second one in the group by. So now actually instead of that, what I'm going to do, I change my mind. I'm gonna still having the aggregation in the second step. So we need the customer key. We have the definition of our customer segments. And now I'm gonna go and use the subquery where I put the aggregation as a second step. So my friends, that means this is again a second intermediate result. You can of course put it in a second CTE. So that means this is the first intermediate result where we have created the lifespan and the total spending, and the second intermediate result is creating the customer segments, and the third step and the last one is by doing the final aggregation. So we can do it like this: select our dimension customer segment, then we're gonna go and count the customer key from our subquery. So this is our subquery, and don't forget to group by our dimension customer segments. I think I have it wrong. Alright, so this is the subquery, and this is the final step where we are aggregating everything. I'm gonna go and order the data by the total customers like this. So now let's go and execute the whole thing. Well, descending, not ascending. Okay, so now we can see from our results, the highest number of our customers belong to the category new. So we have 14,000 customers that are new in our business. And then the second category, we have the regular customers. So we have around 2,000 customers. And VIB, we have a lot of VIB customers. So we have 1,655 VIB customers in our business. So with that, my friends, we have done data segmentation. It is amazing. We have segmented our customers based on their spending behavior. And as you can see, all those informations are totally derived from our data, and this helps us to have a deep understanding of the behavior of our customers. And of course, this can help as well making smart decisions. Alright my friends, so with that we have covered the 5 different types of data analytics that we can do using SQL. Now what I usually do as the last step in my project is that I try to collect all the different types of explorations and analysis that I have done in my datasets so that I can put everything in one, for example, view or table, and then offer it to other users. And with that, it's gonna help the other users or stakeholders to make quick analysis for decision making. So now what we're gonna do, we're gonna have like some kind of requirements where we're gonna bring a lot of different analyses in one big script in order to have insights about one object, like for example the customers. So now I'm gonna show you the requirement of this report and we're gonna analyze it and start writing the scripts. So let's go. Okay friends, so now let's create a customer report, and here are the requirements for the report. So now we have like a general statement. It says this report should consolidate key customer metrics and behaviors. So it says first we have to gather all the details about the customers, like names, age, transaction details, and then we have to segment the customers into categories: VIP, regular and new, and as well by the age groups. And we have to provide as well aggregations like the total order, total sales, quantity, products, and so on. And we have to generate important KPIs like the recency, the average order value, the average monthly spends. So we have a lot of things and we're gonna do it step by step. Alright, now I'm gonna take you step by step in the process of building a complex query that I usually use in order to build a report. Now the first thing that I usually do is I start selecting the data from the database, and I usually start with the fact table. So this is my starting point, and then usually I join it with the dimensions, and here I use left join. And after that I think about how to filter the data, because usually we don't need all the data that is available in the database. And of course in the result I will not be selecting all the columns. I'm gonna be selecting only the relevant columns that I need for my reports. So since we have like complex query, we will be dividing the process into multiple steps, and I usually call this step the base data, and this is gonna be the foundation, the scope for the next steps. And since we have like multiple steps, I'm gonna put this in a CTE, so we have this as an intermediate results. And what we're gonna do in this step as well, we're gonna do few transformations, like maybe calculating and deriving new columns, maybe formatting the date, so some basic transformations. So now let's go and build this result for our report. So the first step is retrieving the core columns from the tables. So let's go and do it together. So we need of course our fact table, fact sales, and we need our dimension, gold customer, and as usual we're gonna go and connect them. Alright, okay, so this is the basic. And now what we're gonna do, we're gonna go and retrieve all the columns that we need for our reports. So let's start picking stuff. So order number, let's get the product key, the order date, sales amount, quantity, and I think that's all from the facts. Let's go and get few informations from the customers. So let's get the customer key, the customer number, the first name, and as well the last name. And what else? We can go and get the birth dates because we have to create the age groups. So birth dates. Let's go and query. So I think those are all the columns that we need in order to do the next steps. And now before we go and proceed with the aggregations, what we're gonna do, we're gonna think about filtering the data. As I recall, we have some orders where the order date is null. So I'm gonna go and remove those stuff. So order date is not null. So that means in the first query, the base query, not only I'm selecting the columns that I need for the reports, also I'm defining the scope of the datasets by filtering the data. So you can as well make the scope here only 1 year or something. Now what else we can do is to think about all those columns and whether we can do any type of transformations in order to prepare them for the aggregations. Like for example, I'm gonna go and say, you know what, instead of first and last name, I'm gonna put them together in one. So it's gonna be the customer name. It's better than having like 2 columns. So let's go and do it. So we're gonna say concat, and then we're gonna start with the first name, and we're gonna have a separator between them. You can have like a minus or a white space like this, and after that the last name. So let's call it customer name, and we can go and get rid of those 2 columns. So let's go and execute, and with that you have everything in one column. Now another thing that we can prepare, that we don't need the birth dates, we actually need for our reports the age groups. So that means we have to go and calculate the age. So let's go and transform it. So date diff, we want it in years, the birth date, and the current date from system, and we're gonna call it age. So let's execute again. Perfect. So with that we have all the data that we need for our reports. Let's go and put everything in one CTE. So I'm gonna call it with base query as and put everything in this CTE. And I'm gonna go and put this comment over here inside the CTE. Perfect. And now we're gonna go and write a query from the scratch based on our intermediate results. So base query, let's execute. All right, so now by looking to our report, with that we have the important columns, right? So now in the next step, we're gonna do aggregations on top of these intermediate results. So here we're gonna do all the aggregations that is needed for the report, and we're gonna put everything again in a CTE as an intermediate results, which makes everything modular and easy to read. So now let's go and do the necessary aggregations on the result that we have previously prepared. So that's why this is very important as a second step in our report. Always tend to make a separated CTE only for aggregations. So let's go and do that. I'm gonna go and select again all the customer informations like the customer key, number, age. So I'm just gonna copy and paste and put it over here. And we just need the column names. So the key, number, name, and age. Now after that, we're gonna start doing aggregations. So what do we want to aggregate is first, for example, the total number of orders. So we're gonna go and count distinct order number as total orders. So this is one aggregation. We can go and summarize all those sales amounts as total sales and the quantities as well. So sum quantity as total quantity, and as well we can go and count how many products did our customer order. So the product key as total products. So what I'm doing now, I'm just looking to our intermediate results and try to figure out what we can aggregate. For example, it makes no sense to aggregate, for example, the ages, right? So from the order number, we have total orders, total product, sales amount, quantity. And from the right side, we cannot aggregate anything. And that's because they are the details of the customers. But from the fact table, we can do a lot of aggregations. So now what we can do with the order date over here, we can, for example, find the last order dates from our customer, which is really nice information. So we can say max order date as last order. And of course, we can go and calculate the lifespan. And that's we're gonna need it, as you remember, in order to categorize our customer. So I will just copy and paste it from the previous query. It is the date diff month between the first order from the customer and the last order of the customer. So, and we call this lifespan. Okay, so we derived two measures or aggregations from the order date. Now I think we have done everything possible, and what is missing, of course, is to have a group by, because we are doing aggregations and we are grouping by the customer details. So gonna be customer key, customer number, name, and age. So I think we have everything for our aggregations. Let's go and execute it. A list of all customers, and we have few details about the customers, and now we have a lot of measures. So the total order, total sales, total quantity, products, the last order, and the lifespan. And with that, we have covered this part over here where we have provided aggregations on the customer level. So we have the details and we have the aggregations. All right, so with that, we have now all the preparation that is required to build the final results. So it really depends on the scenario. If it's possible, we can take all the data from one CTE, or if it's needed, we can get it from multiple CTEs. But in our scenario, we're going to take it from the second CTE, the aggregations, and we're going to prepare the final results. So here we're going to bring everything together, and we might introduce final transformations that is needed for the reports. So let's go and write the query for the final results. Now we can go and start segmenting our customer and as well creating the KPIs. So let's go to the third step. I'm gonna go and put this in a CTE. So let's call it customer aggregation. And now based on these results, we will write the final query. So I like always to put a comment about the steps. So the first CTE is the base query where we just joined the data and prepared it. And then the second query is for the aggregations. And the final one is for the final results. So let's go and start writing our final query. We will start with select, and I'm gonna go and list again all the customer informations. So I'm gonna go and get again same things. We have the customer key, customer number, name, age, and so on. And now after that, we need to create the age categories. And now after that, I'm gonna go and get all those measures as well from our query. But of course, without the calculations, I just need the names of it. So with that, we have everything from our previous CTE. So the customer aggregation. Okay, so let's just test it. Now everything is working. So now what we have to do, we have to create few categories, age category, and as well the segments of the customers, right? For segmenting the customers, we have already done the query. So I will just copy and paste it from the previous analysis. It looks like this. If the lifespan is at least like 12 months and the sales above 5,000, then AVIB. If it's less or equal 5,000, then regular. Otherwise, it is a new customer. So this is our first segment. But the second segment about the ages, we're gonna go and build it now. And again, how we gonna do it? Case when. So if the age, for example, less than 20, then the customer is under 20. Let's make another range where we say if the customer age is between 20 and let's say 29, then we have the second range, and we can keep repeating the same thing for the second one. It really depends how many categories you want to build. So 30 and 39, I belong to this group. Now the next one, let's have the 40s as well, right? So 40, 49, same thing over here. And now else, let's say 50 and above, right? And above. So let's go and end it as age group. I just want to sort it a little bit like this. Okay, now it looks nice. So with that, again, we have turned a measure into a dimension, and let's go and execute it now. So now by checking the results, we have the details of the customers, and now we have a new category. So as you can see, it is working. 54, it is above 50. This is in the range between 40 and 49. We have here 67 above 50. I believe we don't have any customer that is below 20, right? Or even between 20 and 30. Okay, so with that, we have created our two categories, and by looking to the reports, you see we can segment the customers now into categories: the VIB, regular, new, and the age group. And with that, we have covered all those three requirements, and we come now to the last requirements. We have to calculate the following KPIs. Now the first one, it is an easy one. It is the recency. How many months since the last order? We have calculated over here the last order for the customer. It is this one, and now in order to find the recency, it is very simple. So all we have to do is to take this over here. I will just put it maybe after the segmentation, and all what you have to do is to use the date diff as usual. So month is the last order date and the get date. So as you can see, we are using this setup like in many analyses, right? We always find the differences between a date from our datasets and the current date and time. And with that, we will get the recency. So let's go and execute it. Now you can see how many months since the last order of the customer. And of course, you can go and test it using the last order date. And this is really important in order to understand whether the customer is still active or inactive. Okay, so this is for the first easy KPI. Now let's go to the second one. It says calculate the average order value. So how are we gonna do this? Let's go back over here. Now in order to compute the average order value, we have to divide the total sales by the total orders. So how many revenue did the customer generate? And we divide it by the total number of orders. And after that, we have to find the average. So it is very simple. Let's go and write that. We're gonna go to the end of our table where we're gonna put our KPI, and I'm gonna say here compute average order value. So as a shortcut, AVO. So we say total sales divided by total orders, and let's call it average order value. So let's go and execute it. And if you go to the last over here, you can see the average order value of our customers. But now if you are dividing numbers together, you have to be careful that you are not dividing by 0, otherwise you will get an error. So imagine that a customer has 0, didn't order anything, you might get an error. In our scenario, we don't have that because we are starting from the order table or the fact table, but still I like to make sure this never happens. And for that, I usually go and use the case when statements. Very simple one. If the total orders is equal to 0, then make it 0. Otherwise, do the calculation that we talked about. So like this, and at the end we will add an end. So that's it, and with that I make sure we will never divide by 0. So that's it. It was simple, right? Let's go to the last KPI, the average monthly spend. So how we will calculate that? Compute average monthly spend. So now since we are speaking about the spending, that means we need the total sales, right? So how much sales did the customer generate totally, and then we divide it by the number of months, and with that we will get the average monthly spend, right? So that means we can divide the total sales by the lifespan. As we calculated, it is the period where the customer has been active from the start until the end. Okay, so now let's do it step by step. First, we have to be careful that we are not dividing by 0, and I believe in the lifespan we have zeros. So what we're gonna say, as usual, case when lifespan is equal to 0, then this time we'll not make it 0. The customer exists only for 1 month. So what we can do, we can get the total sales of the customer, and we don't have to divide it by the month in order to find the average, because the average is equal to the current total sales. So with that, we make sure we are not dividing by 0. Otherwise, we're gonna have our calculation. So total sales divided by lifespan. So the total sale divided by the months, and with that we will get the average monthly spend. So and as, and we're gonna call it average monthly spend. Perfect. So let's go and try that out. Let's go to the right side, and with that we have our third KPI, and we have the average monthly spends. And with that, guys, we have now a full report about the customers, and we have covered all the requirements. Alright, so with that we have the final results, and we have fulfilled the requirements. So what we're gonna do, we're gonna take the whole query and put it in the database as a view. And once we have the view, the report in the database, we can share it with the others. Now the other data analysts in the team can go and maybe create a dashboard in order to visual the data using a BI tool like Tableau or Power BI. But in this scenario, the user gonna go and connect your review, the last prepared data, to the dashboard, and with that the user can quickly generate insights without doing a lot of steps in order to prepare the data for the visualizations. And of course the data analyst can go and connect the dimensions and facts, but having this one solid view is gonna be like way easier to consume. And of course the data analyst can as well write a query on top of your view in order to generate a quick insights. So as you can see, using only SQL, you are covering a lot of complex steps in order to make the data ready for reporting and analysis. And this is what usually happened in real projects. So we're gonna go and put the query in the database so that the others can use it. So what we're gonna do, very simple, create view, and we're gonna put it in a code layer, and we're gonna call it report underscore customers, and then ask like this, and let's go and execute it. It is successful. Now if you go to our database and check the views, you will find a new view called gold report customers. And now all what you have to do is to go and have a simple select, so gold reports customers, and you will get an amazing report about the customers. This kind of reporting, it is very important because you are giving a full picture, 360-degree view of all your customers. So you have details, categories, measures, everything in one go, and it's gonna make life easier now for any user of this view to quickly understand the data and generate maybe insights based on this one view. That can help, of course, your customers. So I just want to show you now what this means if a user using your reports, so either in SQL or maybe they're gonna go and connect it to a Power BI or Tableau, they can generate immediately insights. So for example, if they go and say count customer number, so as total customers, and then they're gonna go and take any dimension, for example the age group, so something like this, and then group by the age group. We'll just put it here first, and then they're gonna go and add any other measure, for example the total sales, and any other measure that you have in this view, and then execute, and quickly they can do analysis on top of your view without having them to go to your fact and dimensions. So this is like one extra prepared layer, the data model that you have built. And if you don't want to group it by the ages, you can go and have the customer segments, and it will be working. So quickly they can analyze the new derived informations that you have prepared in your reports. So guys, this is amazing reports about the customers. And now what you're gonna do, you're gonna go and prepare the second report where you have to build complete insights about the products of the business. It is very similar to the customers. So we want to generate a report for the products. You have to provide details like the product name, category, subcategory, and the costs. You have to segment the products by their revenue. So you can have categories like high, medium, and low. And then you have to provide the basic aggregations at the level of the products and then calculate few KPIs. So as you can see, it is very similar to the customers. And now what you have to do, you have to pause the video, follow the same step as the customers, where we join the tables, create aggregations, and put everything like in CTEs. And at the end, once you are done, create the view where you have the report about the products. So I'm gonna go now and do it offline, and I will see you soon. Okay, my friends, I hope you are done with the report. I'm gonna show you quickly how I've done it. So I've just created a new view called Report Products. And then we start with the base query, where we have joined the fact table with the dimension products and collected all the columns that we need for the reports. And we put everything in the first CTE. So this is the first step, and there was from my side no need for any transformations over here. So we go now to the second step, and here we have to put all the different types of aggregations in one go. So we calculate the lifespan, the last sales order, total orders, total customers, sales, quantity, and as well I have created the average selling price of the products. It is very simple, we are dividing the sales amount by the quantity. So this is the basic aggregations about the products, and finally we have the final query. So we start with selecting the basic informations about the products. So we have the key, name, category, and then we have here the recency, and we have our new segment. This one is very easy for the products. So we are saying if the total sales is higher than 50,000, then this is a high performer, and if it's like between 50 and 10k, then this is a mid-range, otherwise it is low performer. So the segmentations of the products is very simple, and after that we have like all our measures that we aggregate in the CTE, and now we come to the two KPIs. It is very similar to the customers. So the first one, the average order revenue, it is simply dividing the sales by the total orders, and you have to take care of the zeros, of course. And the average monthly revenue, we divide the total sales by the lifespan of the products. And of course, if the lifespan is 0, so it is only 1 month, then it is the total sales. And with that, you generate the average monthly revenue. So as you can see, it is very similar to the customers, but still the focus here is the products. Now, of course, we put this query in view. So we have the report products side by side by the report customers. And now we have really amazing report about the products where we have everything. So we have a lot of details about the customers. We have as well a dimension in order to segment our products. And we have a lot of measures that are really important about each product. So we have the total number of orders, sales, how many customers did order the products, the average price, the average revenue, and the monthly average revenue. And this gives you really deep insights about each product of your business. And of course, this is very helpful in order to compare the products, right? And now, of course, this is core analysis that you're gonna need it a lot in your business. That's why we offer it as a view. So I think we have now 2 amazing reports about our data. Alright, my friends, so now don't forget to put all your work in the Git repository in order to share it with the others as successful projects. So as usual, we have the datasets, documentations, and as well the scripts that you have done through these projects. And here I'm putting everything together. So we have all the activity of the exploration as well with the advanced analysis that we have done. So we have the change over time, the cumulative analysis, performance, data segmentations, part to whole analysis, and as well our 2 new reports. So I recommend you, if you haven't done that yet, go and create now a repository, put all your work there to make sure that everyone can access and see your work. And my friends, don't forget to add nice commenting in your code, and formatting and styling your code should be perfect. So if you haven't done that yet, go and do it now. Alright, my friends, so with that we have done the last step in our roadmap. We have created 2 solid reporting for our users, and with that we have completed all the steps of our advanced analytics projects. And with this project and the previous projects, you can see now the full picture on how to do data analytics on any datasets using SQL. So starting by the first step where we have explored the database and end up having a very solid reports where we have consolidated everything in one view. And with that we have now really great understanding about the business, about our data. And now what you can do, you can go and grab any datasets in the internet and you can go through all these phases again. And I promise you at the end, you will have a full picture and understanding of the business. And this is what I exactly do in each project if I want to understand any type of datasets. Hey friends, if you're still here, I'm really proud of you because with that we have covered 3 different types of data analytics projects using SQL: data warehousing, exploratory data analysis, and advanced analytics. So as you can see, doing projects is always amazing because you will have deep understanding why we are learning SQL, and with that you have learned different types of real skills that you need in projects. And I'm gonna be really honest with you, I shared with you everything about SQL. So all what I know about SQL, I shared it now with this SQL course, and I hope this knowledge can help you in your career and in your life. So if you like my content and you want to support the channel, don't forget about subscribing, liking, and commenting because it's gonna really help the channel reaching the others. And if I got your support, I will keep publishing this type of content. So thank you so much for watching, and I will see you in the next course, Python course.